Good morning, 8th grade. Today it's lesson 11-2, rational functions. What are rational functions? Well, let's find out. So the parent function for rational functions is this here, which should look very similar to the inverse functions where you had y equals k over x or xy equals k. Those are the inverse variations and the inverse functions. So the parent function for rational functions is like that. Basically y equals 1 over x. Now the graph here should look very similar to some of the ones that you saw yesterday. And domain and range here, first of all, the domain x cannot equal 0. That's because you cannot divide by 0. So if x cannot equal 0, and there's a 1 on the top, then y, the range, y cannot equal 0. And if you look at this graph over here, x does not equal 0, and y does not equal 0. Y's go up from 0 and down from 0. Because if you have a negative 1, for example, right about here, negative 1, then that would be negative 1. Because negative 1 right there would work. Now, excluded values are any values that you'd put in for x that would make the denominator 0, which you can't divide by 0. So those would be the excluded values. Now, I'll give you an example of that in a little bit. So now these are some examples that you'll find on page 684. Here's y equals x over x minus 7. So if you look at excluded values, things x can't equal, then hopefully you see that x can't be 7, because 7 minus 7 would give you 0. Give me another example. Y equals 4, 3x plus 9. Have to figure out what could x not be, and one way to do this, if you get stuck, is you could take what's on the denominator, 3x plus 9, make it equal 0, and you'd get 3x equals negative 9, x equals negative 3. If that's the way to make it 0, then that is your excluded value right there. Now, when you have a rational function and you end up with these vertical lines or a horizontal line that the function never touches, there's a special word for that on page 685, and that word is the asymptote. A-S-Y-M-P-T-O-T-E. There it is. The asymptote. Those are the lines that the function approaches but never touches. And you should be able to name that. So in this one, in your parent function, it would be x equals 0 and y equals 0. Now, the general form of this would be like this. Y equals a over x minus b plus c. And if you want to figure out what the asymptote functions would be, you can look here and you can see that there's going to be a line that's going to approach where x equals b. And the reason for that is, if x equals b and you're subtracting b, x can never actually be b. So you're going to have one that is, your asymptote is where x equals b. Now to extend this a little further, if a is not 0, and this is not going to end up at 0, then the other one would be y equals c. The other asymptote would approach that, because the only way you'd get y to equal c is if everything here went to 0, which it can't. So you're never going to get to y equals c. It's a lot easier to see this on an example which I'll give you next. So hold on. Now one way you can do this is if you actually graph it. So you can just make a table of values and graph your rational function and get your cute little curvy lines. But you can also start to look at it and figure this out. For example, in this one, x cannot be 0. So that's your first one, is x equals 0 is one of your asymptotes. And then if this was 0, then you'd have y equals -4. So since this cannot be 0, especially this cannot go to 0, then your y equals -4 is in the other asymptote that you're never going to get to. Here's another one. Now, right away, when I look at this, I notice there's nothing back here. So I'm pretty sure that since this can't go to 0, then y equals 0 is going to be one of the asymptotes because it can't get to 0. The other thing is, this was kind of like the example we gave before, which was if you have x minus b, then x cannot equal b. So in this one, the number that x cannot equal is -1. So my asymptote should be x equals -1. That's the vertical one, and then that's the vertical one, and then the horizontal one is y equals 0. So it can never equal -1. So once again, I'm going to try to do this just by looking at it, and I should have an answer. Looking for the answer. There it is. Y equals 1. That's going to be, let's see, y. That's going to be the horizontal one. And the vertical one, I'm pretty sure x cannot equal -2. So x equals -2 is the vertical asymptote, and the horizontal asymptote is y equals 1. There you go. And by the way, I will throw in here that page 686 has a great summary of all the functions. It has quadratic, exponential, radical, and rational. And it shows the parent function for each one. And so I'd really go back and make sure you have that in your notes. That's a pretty good one to have in your notes. Now, one thing you should be able to do, you should be able to look at a graph like the one on 687, number 35, where they give you the rational function graph that looks like this, and they give you the asymptotes, which are not going to look as good on my beautiful picture. It looks generally like this. And as I look at it, right here, that's 3, and this is 2. So the x that you never reach is 3, and the y you never reach is 2. And then it says, can you create a possible function for it? Because we've given the asymptotes, so now can you create a function for it? Well, I know that, as we've seen in the other ones, we're going to have that for the asymptote for y. Now the other one would be 1 over, and let's see, if x can't be 3, there must be an x minus 3. So that is how you take the graph and go back to a rational function. And then one more thing, I want to show you ones where you get a slightly different asymptote. And you'll have to do a couple of these, and I'll show you one that's on there. So hold on while I clear my board. Now in this one, they actually switch the directions around. They tell you to graph it first, and then identify the asymptotes, because it's not as easy just by looking at it. So we'll do that just so you can see how things change a little bit. First of all, x squared minus 1 on the bottom. So I know that x cannot equal 1, but it also cannot equal -1, because -1 times -1 would give you this at 1, you need a 1 minus 1. So it has to be both of those when there's a square. So that's kind of weird there. So that means if I'm going to make a dotted line at x equals 1 and at negative 1, perfectly straight. Now, you need to graph this because you would start to think, well, the other one, the asymptote for y would be 0 since there's nothing out here. But that's why you want to graph this one first. So let me make a table of values. And let's see, let's do my usual negative 2, negative 1, 0, 1, 2. So if I have 0 on the bottom, that's negative 1. That's going to be negative 1 for y, x, y. I put 0 in there, 0 in here, 0 minus 1, there's a negative 1 on the bottom, and 0 on the top. Wait, did I say negative 1? Shouldn't that be 0? Because if it's 0, negative 1 on the bottom, 0 on the top. Okay, let's try that again. How about 0? Alright? So I've got a spot right there. Let's see, 1. If I put 1, I can't put 1 on the bottom, so we know that, so I'm going to ignore that for now. And how about 2? What happens when x is 2? 2 times 4. 4 minus 1 is 3. And x squared would be 4. So I have 4 over 3. So that's 4/3. So when x is, so when x is 2, y is 1 1/3. So I'm going to put a dot there. Okay? Looks like I might need to go higher. Negative 1, we already said it can't be negative 1. So negative 2, I believe we're going to get a very similar answer to that. So negative 2 times negative 2 is 4. 4 minus 1 is 3. And so I'm going to get 4/3. So it's going to mirror on this one. So 2, we're going to be there. Alright? Still not too sure what our graph looks like. I'm going to take a peek here just to make sure I know what it looks like. Alright, so far, we have no idea what to draw. Let's try something less than 1. So let's do 1/2. Because I know I need something that goes in here. And I know this is 1 and this is negative 1. So I'm going to do something like 1/2. So 1/2 times 1/2. Oh, let's see, what is 1/2? Half of a half, that sounds like 0.25, right? So if I'm doing 1/2, whoops, forgot my pencil. 1/2 for x, that's going to be 1/4. And what happens if I do negative 1/2? Negative 1/2. Well, let's see, that would still be on top and on bottom. It would still be 1/4. But 1/4 minus 1. Uh-oh, did I do that wrong again? Let's go back to our other one. I hope you guys are paying attention because I lost it there. Let's see. So if I have positive 1/2, that's going to be 1/4 and 1/4. Alright, now 1/4 minus 1. 1/4 minus 1 is negative 3/4. Now I have 1/4 divided by negative 3/4. So that's 1/4 times negative 4/3. 1/4 times negative 4/3. Looks like I'm going to have negative 1/3. Now, if I have negative, I still think negative 1/2 is still going to give me 1/4. Negative 1/2 squared. Still going to be positive 1/4 for both. I'm going to have the exact same thing, negative 1/3. So now it looks like this. Let me go back to red. At 1/2, I have negative 1/3 and negative 1/3 here for negative 1/2. So it's beginning to look like in here I'm going to have something that does this and something that does this. It still doesn't help me know anything about where what y can't be. But let's take a look. Let me clear some stuff and we'll go from there. Or maybe I won't clean it up because it'll mess up too much of the other stuff. So now I need to figure out, I know I have my 2 and negative 2. 2 and negative 2. Let's go out to 3. Let's see what happens when we get to 3. First, we'll do 3 for that. So, if x is 3, let's see if I can do this one right. That'd be 9 minus 1 on the bottom. That would be 8 on the bottom. That's 9/8. And I'm pretty sure I'm going to get a negative 9/8. But let's make sure. Because negative 3, if I made that negative 3, so let's see, that's still going to be 9. That's still going to be 9. So you're still going to get 9/8. So at 3, oh, back to red. At 3, I'm going to get 9/8. That is 1 and 1/8. So that one's getting lower yet. I think I'm starting to figure something out here. So we're getting a little bit lower at 3. A little bit lower at 3. Now, if I get closer to the things we can't have, the 1, if I start to do something just above 1, since I know our asymptote can't be 1 and negative 1, if I do something just above it, like 1.1, let's do 1.1, 1.1, and then negative 1.1. We'll do that in a minute too. So 1.1 squared is 1.21. Okay, 1.21, so I'm going to have 1.21 on top, right up here, 1.21 on top, and then I have 1.21 minus 1, so that means I'm going to have 1.21 divided by 0.21. Oh, pencil. So now, 1.21 divided by 0.21 gives me, oh, almost, it's 5 3/4, 5.76. So it looks like it just right above 1, I'm going to be way up here, and I'm pretty sure it's going to mirror. So this one certainly looks like this. And it looks like the y that I never get to must be 1. Let's see if my answer is correct on that. So right there, and you do it on graph paper, it will be even more exact. So my y asymptote points out to y is 1. So there's an asymptote, here's an asymptote, here's another one. This one has 2. Alright? Let me clear off and just give you a little bit of run through on another one, and then we're done. Okay, so this is number 38. And on 38, I can tell right now that one of the x asymptote, the vertical one, is going to be 2. Because can't have 2 down there and get a 0. 2 times 2 would be 4. 4 minus 4 is 0. Can't do that. Now, you're going to have to put in some values and see what you get. Start graphing it. So I'll start with 0. So I'm pretty sure that if I put 0 in there for 38, I'm going to get negative 3/4. Because if this is 0 and this is 0, that makes those 0. I have 3 over negative 4. That's negative 3/4. So my very first one is 0 and negative 3/4. Oh, pencil again. So for 38 and 40, you really are going to need to graph it and then see what you get. See what y cannot be. Alright? So what you're doing on this one is you're doing 687 to 688, numbers 12 to 40 even. There you go. 687, 688, 12 to 40 even.